Okay, so for today's notes, a lot of it you've learned before. There's one thing that you haven't. So one thing that's big on the Harper test is what's called interval notation. So as you see on this note sheet, on the left you have a whole bunch of different inequalities. In the middle you have all of the number lines that go along with them. None of that should be new. So here we have x is greater than 3, so I have an open circle at 3 and I shade greater than. Here I have x is less than or equal to, yeah, it should be negative 3, so add a little negative in there. Negative 3. So I have a closed circle at negative 3 and I shade lower than. What does the open versus closed mean?
It's greater than, equal to, or it's just greater than, or less.
Right. If it's equal to, it's a closed circle. It means that it's included. That number is part of your solution. If it's open, that number is not included, so it's not part of the solution set. In the third inequality, we have x's between negative 4 and 3. Anytime that you have a single inequality like this, you're going to be shading in between. So I'm shading in between negative 4 and positive 3. And then in the bottom one, I have an or inequality. Or is when you shade outside. So I have x is less than negative 5, so I have an open circle at negative 5, I shade less than. Or x is greater than 5, so open circle at 5, shade greater than. Okay, so interval notation, Fred, yeah?
Can you have a situation where you have one where it says x is like greater than or equal to negative 5, or x is greater than 5? Like we have one where it's like closed circle and an open circle.
On the same number?
Yeah. Like for an or, right? Yeah. Or.
Yes. We wouldn't give you one like that, though.
Okay.
That one is just a very complicated way of writing one inequality, so you wouldn't have that. Okay, so interval notation is just another way to write an inequality. So one thing that you guys need to fix that is not on your note sheet, here you need to have a bracket, not a parenthesis. So the way interval notation works is you write the lower bound for your inequality and you write the upper bound. So in the case of our first graph, we have 3 comma infinity. What that says is I start at 3 and I go in the positive direction without stopping. If you look at the second one, that's negative infinity comma negative 3. So it's saying I start at the negative numbers and I come up to negative 3 and I stop. So the negative infinity is what I call the lower bound. The negative 3 is what I call the upper bound. This third one means that I'm graphing from negative 4 to positive 3. You guys follow? Okay, what is one difference that you notice in this interval notation between some of the intervals? So some have infinity, some don't. What else? There's one really big difference that you should notice.
Brackets and parentheses.
Yeah, do you notice how some have brackets and some have parentheses? Okay, anytime that you have a bracket, that is included. So what I mean by included is a closed circle. So anytime you have an equal to, where you have a closed circle, you're going to have a bracket. So in the case of the first inequality, I just have greater than, not greater than or equal to. That's why I have a parenthesis on the 3. Second one, though, where you have a closed circle on the negative 3, that's where it's a bracket. Now, something that's very important to know is infinity is always a parenthesis. Whether it be positive or negative infinity, it's always going to be a parenthesis. The reason that is, infinity is not a number. So you can't say that you include infinity because it's not a number, it's just an idea. Okay, and then the last one that's kind of tricky is the or statement. So for an or statement, you have 2 different shadings, so you're going to need 2 different intervals. So the first interval is for the shading on the left, second interval is for the shading on the right, and then you write this U in the middle. U stands for union, it means or. So the U just means or. Any questions before we try some on our own? No. Okay. So I'm going to do 1 or 2 with you, and then I'm going to have you guys do some. So we are going to start with problem 1. Mine says x is greater than or equal to -1. Yours is +1, isn't it? Okay, here's my suggestion. I would suggest that you draw a number line first, and then that you write the interval. So I'm going to do my number line. X is greater than or equal to 1, so that means I have a closed circle at 1, and I get bigger than that. Okay, so in interval notation, the lowest number I reach is 1, and then I go all the way in the positive direction, which is positive infinity. Now, the 1 has a closed circle. Mine kind of looks open, but it should be closed. It's included, so it has a bracket. Infinity always gets a parenthesis. Next one that I would like us to do is problem 4. Again, I'm going to suggest that you draw a number line first. So I have my -2 and my 5. -2 has an open circle, but 5 has a closed circle. Where do I shade? In between or outside? In between. So in this case, my lowest number is -2. My highest number is +5. -2 is an open circle. It's not included, so it gets a parenthesis. 5 is a closed circle, so it is included, so it gets a bracket. Yeah, we did. For the first one, you should have a number line. You should have shaded in between 0 and 5. The lowest number is 0, highest number is 5. Neither of them are included, so they get parentheses. Problem 3. At 7, you should have an open circle. It's less than, so it goes to the left. Okay, this one I find that people miss something a lot. There is no lower bound, so we're going in the negative direction forever. So it goes -infinity, 7. So I find a lot of people forget the negative. So we're going in the negative direction, not the positive. Infinity always has a parenthesis. 7 is not included, so it also gets a parenthesis. And then problem 5, we have x is less than -4, so open circle, go less than. X is greater than or equal to 6, so close circle at 6 and go bigger. And or you're going to need to have two intervals. First one is going to be -infinity to -4. Second one, I start at 6 and I go to positive infinity. And then the way to write the or is with the u. So, any questions on those? Okay, so again, the reason we're learning this is Harper only accepts interval notation. So if you write anything as an inequality, they will not accept it. That was the new stuff. Any questions on the new stuff before we go on? Okay, so flip to the next page. Next thing we need to talk about is domain and range. This is stuff that you have done before, we just have not done it in interval notation. So, as a review, what does domain mean? X, range is Y. Okay, so looking at problem 6, what is the first x value that x starts out at? What is the lowest x value that x takes on? So x is left, right, -2. And what's the highest that it goes to? +2. They are both included, so they both get brackets. Range is Y, so that's the up-down. What's the lowest the graph ever goes? -4. What's the highest it ever goes? +4. Both are included. Do you guys know what that shape is called?
Ellipse.
It's called an ellipse. Yes. Oval is the non-math term, like the everyday term. It's called an ellipse in math, though. Okay, problem 7. Domain. Domain is the left, right. Does the graph forever go in the left direction? No. What is the first number that x takes on going to the left? -3. Okay, does it forever go in the right direction? Yes. -3 is included, so it gets a bracket. Infinity always gets a parenthesis. Range is y, the up, down. Does the graph forever go down?
Yeah.
Yes. Does it forever go up?
Yeah.
Yes. Any idea how we would write that?
Negative infinity, positive.
Yeah, very good. Negative infinity, comma, positive infinity.
Both brackets, or not brackets, parentheses.
Both parentheses, because infinity always gets a parenthesis. Okay, problem 8. This one should have arrows on the end of it. So put some arrows there. Problem 8. Domain. Domain is the left, right direction. Does the graph forever go in the left direction?
Yes.
Yes, forever in the right direction.
Yeah.
Yeah.
Yes, so the domain is negative infinity to positive infinity. So the graph is going down, but it's also going left and right at the same time. Range. The graph forever goes down,
But stops at 1.
but it does stop. So it goes in the negative direction forever, but you stop when you get to 1.
Does the order matter? Because I wrote it as 1, negative infinity.
Yes, the order matters.
Because
How would you know you're writing it the right order?
Negative infinity always has to be first, positive infinity always has to be second.
Okay.
Does that answer?
Yeah, so, yeah.
Okay, can you guys ever think of a graph where you have a number that's not included? So here, all of our numbers have brackets. Can you think of a single time where you have a graph where you would not have a bracket?
2 lines.
Parallel lines.
Yeah.
No. Thank you, though.
Maybe one
A
line.
random point isn't a graph. Dotted lines.
What?
Dotted lines.
Asymptotes.
Asymptotes. Yeah, an asymptote is the only time where your where x and y doesn't actually take on that value.
Oh, because it's not equal to whatever. Okay.
Right, so y might approach 0, but it never hits 0. Do you remember that with an asymptote? You never actually hit the asymptote?
Otherwise, it comes out fine.
There are other cases, but we have not done them. Okay, moving on to 9 and 10. These are two graphs that, believe it or not, we have done. You just may not remember them. Problem 9. Do we have any recollection of what this looks like? Y equals the square root of x plus 3? What a square root graph looks like? Okay, if we have no idea, what should we probably do?
Oh, do that thing.
I don't know what the thing means.
Oh, yeah, that one thing.
That's why you made force.
That one thing.
Come on, if I gave you this graph and I said graph it,
We inverse it.
what?
Square.
Plug numbers in. Yeah, guys, come on, plug numbers in. So, let's make ourselves a little table. Good ones to start out with are -2, -1, 0, 1, and 2. So let's see where that takes us. If we plug in -2, we get the square root of 1. What is the square root of 1? 1. Whew. If we plug in -1, we get the square root of 2. That's not good to graph, so let's not graph that one. If we plug in 0, we get the square root of 3. That is also not good to graph. If we plug in 1, we get the square root of 4, which is 2. If we plug in 2, we get the square root of 5, which is not good to graph. So far, we have 2 points to graph. -2, 1. So, like right here. And 1, 2, which is right here. Now, that is not enough. We're not just going to connect those two.
1b plus or minus 2.
So if the square root is already there, you don't get plus or minus. But good thought. Thank you. We're going to need that later. Okay, so the question is, am I allowed to plug in any numbers I want for x? So I got up to x equals 2. If I continue to go in the positive direction, am I always going to get a number that makes sense? Maybe not a whole number, but am I always going to get something that makes sense?
Yeah.
So if I plug in 4, I'll get the square root of 7. That makes sense. If I plug in 10, I get the square root of 13. That makes sense. If I go in the negative direction, am I always going to get a number that makes sense?
No.
Because we plugged in -1.
It made sense, we just couldn't graph it.
Yeah.
Because it was the square root of 2. What if I plug in negative 10?
In negative 7, you can't do that.
You would get the square root of negative 7. Can we graph the square root of negative 7?
Because
I something.
Yeah, do you guys remember how the square root of a negative number is imaginary? Does that ring a bell at all?
Yeah.
Okay, so what is the lowest value of x that you can plug in where you don't get an imaginary number?
negative 3.
-3. Yeah, that's a really important number. If I plug in -3, I get the square root of 0, which is 0. That's a really important point. So I'm not allowed to plug in anything less than -3 for x, because I'm going to end up with imaginary numbers. But I can plug in numbers bigger. So this is what I end up with. It's half of a parabola.
Yeah.
This is the way that we did it in class. Do you remember you flipped this sign? So you got -3, 0. And then your perfect squares are 0, 1, and 4. So you did -3, you added 1, you got -2. You took -3, you added 4, you got 1. Does any of that ring a bell? That's basically what we did over here without remembering that that's what we did. Okay, domain. Does my x forever go in the negative direction?
No.
No, what does it start at?
-3, 0.
So it starts at -3, it goes to infinity. My range,
Your range has a max, or does not have a max.
nope, it starts at 0, goes to infinity. Yep, it's a bracket on the 0. Okay, problem 10. What is this going to look like? Come on. X squared? Parabola. X squared is going to be a parabola. Do we remember how to graph parabolas?
Negative b over 2, or negative opposite of b over 2a.
Yeah, thank you. The way to find the vertex is the negative b over 2a. What is our b in this case?
-4, or no, 0.
0. B is what's in front of the x, but we don't have an x that's alone. And then we get 2 times 1, so we get 0. I'm actually going to make my table over here. Do you remember putting the vertex in the middle of the table? If I plug in 0, I get -4. So then I'm going to go down 2. And I go up 2. If I plug in 1, I get 1 squared minus 4, which is -3. If I plug in 2, I get 2 squared, which is 4. 4 minus 4 is 0. If I plug in -1, I get 1 minus 4, which is -3. If I plug in -2 squared is 4. 4 minus 4 is 0. Now, is it a coincidence that these match? That those are the same?
No, should match.
Remember how they should by a parabola? A parabola is what we say is symmetric. Okay, so plot these points. Okay, domain. Domain is the left, right. Does the graph forever go in the left direction?
Yes.
Yes, forever in the right direction. Yes. So domain is -infinity to +infinity. Range. Does the graph forever go up and down?
Yeah, no.
No. What does it start at? Negative 4. It starts at negative 4, and it goes to positive infinity. Okay. Okay, so let's start going over 11 and 12. So 11a, show work to find the coordinates of the vertex. That's what we just did, the negative b over 2a. So in this case, our b is 4, our a is negative 1. So here's our a, here's our b, here's our c. So you should get negative 4 divided by negative 2, which is 2. We then need to plug into to find the y. For that first term, you want to square and then do the negative. So 2 squared is 4, so I get negative 4 plus 8 plus 9, which is 13. So you should have gotten a vertex of 2, 13. It looked like you guys were on the right track there, but then got stuck on the domain and range. Okay, so we need to think, what is this graph going to look like? It's going to be a parabola. It has a vertex of 2, 13. What else do you know? It opens down. That's really important. That negative x squared means that it's going to open down. So if we sketch ourselves a little graph, we have the vertex up here of 2, 13, and it opens down. Now, domain is left, right. Does the graph forever go in the left direction?
Yeah.
Forever in the right direction?
But
Yeah. So your domain is negative infinity to positive infinity. Range. The graph forever goes down, so that's the negative infinity part. But it comes up, the highest point it hits is what? 13. That's the highest y value. Any questions on that one? Okay, flip the page. Okay, problem 12. Solve for x, write the solution set in interval notation. Okay, so if I subtract 13, I get negative 8, I think. Divide by 2, I get x is less than negative 4. Over here, I subtract 4, I get 3x is less than negative 15. Divide by negative 3, I get x. 5. Did you remember to flip it? Anytime you divide by a negative, it flips the sign. And then I have an or. Now, I would suggest that you draw this on a number line before you write it in interval notation. So less than negative 4 is an open circle at negative 4, shading lower. Greater than 5 is an open circle at 5 and shading bigger. So you will have 2 different interval notations then, one for the left part, one for the right part. On the left part, what is that going to look like in interval notation? What is the left side going to look like in interval notation?
negative infinity.
Yeah, I go from the negative all the way from negative infinity, all the negative numbers, to negative 4. Infinity always gets a parenthesis. The negative 4 is not included. It's an open circle, so it also gets a parenthesis. On the right, I start at 5. I go all the way to positive infinity.
For like the or
Mm-hmm.
in 12, did you flip the sign because you divided by a negative, you said?
Yep.
Okay.
And then remember, with an or, you have to put the u. Okay, 13. Whew. Okay, I'm going to start by subtracting 4. So then I get 2x minus 5 is less than 7. Now, in the past when we did this, a lot of times you guys just ignored those bars and treated them as decoration. What do the bars mean?
Constraints.
Absolute value. Absolute value. What does absolute value mean? The distance from 0. So
Positive and negative 5.
this is just a number. So I have a number that's 7 away from 0. If I have a number that's 7 away from 0, what is that number?
7 plus minus 7.
Yeah, 7 or negative 7. Do you remember that distance goes both ways? Okay, so the key to this is remembering that you have 2 different equations. So we get 2x minus 5 equals 7, and then 2x minus 5 equals negative 7. Here, I'm going to end up with x equals 6. Here I'm going to end up with x equals negative 1. Now remember that originally this was an inequality, so it's going to have shading. So I have my negative 1 and I have my 6. Both are open circles. In this case, we're either going to shade outside or we're going to shade in between. How do you figure out where to shade? If you know nothing else, what's a good option? Plug in a number, yeah. Plug in a number. What's the easiest number to plug in?
0.
0. Plug in 0. Now, where do I have to plug in 0 to?
The original equation.
The very original equation. So I get the absolute value of 2 times 0 minus 5 plus 4 is less than 11. So this is the absolute value of negative 5 plus 4 is less than 11. Some of you got in trouble here because you dropped those absolute value bars. What is the absolute value of negative 5? Positive 5. So it's positive 5 plus 4, less than 11. True or false?
True.
True. So you want to shade where 0, 0, or where 0 falls, which is the in-between. We still need to write our solution. So the shading starts at negative 1, it goes to 6. They're both open circles, so they both get parentheses. You have to remember with the absolute value, you're always going to get 2 answers. Sometimes it will be shading outside, though.
Instead of making the 7 a negative when you split up the absolute values, I did negative 2x plus 5 and then negative 2x minus 5 and I got the same answer. Is that just like a coincidence or would that work?
You did negative 2x plus 5 and negative 2x minus 5?
No, negative 2x plus 5 and then just the 2x minus 5.
That will also work.
Okay.
Okay. Last thing we need to talk about is problem 14. You saw a few of these in your classwork, but not many. So it says solve for x, check your answer for extraneous solutions. What does that mean, extraneous solutions?
No solution.
What?
All solutions or no solutions.
What we've been doing recently, yes.
Both sides don't equal each other.
Right. So do you remember with an extraneous solution, you didn't make a mistake, but your answer didn't work at the end? So, ideas on how to start this one.
Square both sides.
Square both sides. Now on the left side, that's really nice. You just end up with x plus 5. What about on the right side?
X squared minus 2x plus 1.
Yeah. X minus 1 squared. Remember to square something, that means to multiply by itself. So this is really x minus 1 times x minus 1. The way I do that is with the box. Some of you FOIL. So x times x gives me x squared, negative x, positive 1. So this gives us x squared minus 2x plus 1. Now move everything over to one side. So when I subtract that x, I get negative 3x. When I subtract the 5, I get negative 4. Ideas from here? Yeah, you're going to have to factor. Two numbers that multiply to negative 4 and add to negative 3. Negative 4, positive 1. Setting both of those equal to 0, you get x equals 4 and x equals negative 1. Now, we are told to check for extraneous solutions, so we have to do that. Do that by plugging the numbers in. If I plug in 4, I get the square root of 9 equals 4 minus 1. That works. If I plug in negative 1, I get the square root of 4 equals negative 1 minus 1. Does that work? No, so I get 2 equals negative 2. Now remember, the square root was already there, the square root of 4, so we don't get plus or minus. You just get the positive answer. The only time you get plus or minus is when you put the square root in. So that one does not work. So our final answer, x equals 4. Any questions?